So in this video, I'm going to introduce the concept of compound interest. And there are two types of compound interest formulas. There's discrete compound interest, which is this formula on the left, and there's continuous compound interest formula on the right. And there's not too much difference between them in terms of the variables. See here we have two variable names. We have several. P is your principal, that's your initial investment. A is the final value of that investment after a certain period of growth. R is your interest rate per year. N is the number of compoundings per year. What a compounding is how many times per year you calculate that interest. And the more times you calculate the interest, generally the higher the interest you get paid is. And T is the number of years. And you can see that all these variables are used in the equation on the left, the discrete compound interest. But one of them is missing on the right. On this right equation, we don't have the variable n. And the reason we don't care about the number of compoundings per year is because the rate is continuous. And when the rate is continuous, that means we have an infinite number of compoundings per year. We don't need to put a number on it. We'll get into some examples of this. Let's start with one. This is finding the final value. And if you remember, the final value is A. So in this example, I'm going to say we have a principal of $1,000. We get an 8.2% interest rate, which is good, but not unreasonable. N is 12, so what is that? That's monthly. This is monthly compounding of interest. And the time the investment is invested is 10 years. So I'm going to say, under these conditions, what should I expect the value of my investment to be? So we set up our equation here. This is A equals P times 1 plus R to the N, R over N times to the power of NT. And the reason I'm using discrete compound interest is because I have this monthly stipulation right here. We'll do an example about continuous interest in just a moment. So if I plug in my numbers, remember I'm looking for A, that's $1,000 times 1 plus 8.2%. Well, that's 0.082 if you remember how decimals and percentages convert. There's 12 compoundings per year, so that's 12 for N, and then I'm going to wait 10 years and see what this investment is worth. So, punching this into my calculator here, 0.082 to 12. Let's just go in steps here. I still have 1,000 on the outside. On the inside of the parentheses, I figured that is 1.0068333, and the exponent is 120. So if I take that parentheses value, that 1.0068, and I raise it to the 120th power, I get 1,000 times 2.26417, yada, yada, yada. And then times 1,000 is your last step. So we get $2,264.18. Okay, so nice return on that investment, considering all you had to do was wait and let the market make it grow. Let's do an example now with continuous compound interest. Same numbers. I'm going to say A equals PERT. Sometimes this is called the PERT equation. And what that is 1,000 times the variable E. And if you remember, E's in your calculator, it's 2.71828 something. It's a very special number in calculus. But your calculator knows it. You don't need to remember it. It's 0.082 as the interest rate and 10 years. Okay, so I'm just going to punch that all in one line. 1,000, where is the E button? Here we go. 1,000 E to the 0.82. Okay, so what I get here is, drum roll, $2,270.50. And you can see that's a little better than if I compound the interest monthly. More compoundings generally mean a little bit more interest. And you reach a limit. I mean, daily compounding is just about the same as continuous compounding, but you get a few more cents with continuous. So in the next few videos, I'll do other examples of finding these different variables, finding the principal, finding the rate, given different styles of question.